Hey everyone, welcome back to day 26 of our 30-day Python series. So today is going to be back with powerful NumPy operations we are going to cover, okay? So these are the advanced NumPy functions, all right? So get ready. So let us start with our shuffle function, hashtag shuffle function, okay? Enter hashtag. What is the shuffle function? So it modifies a sequence. It modifies the sequence in place by shuffling its contents. Okay. So let us perform some operations here. So here I'll be giving it r equals mp dot array. Open the bracket, open the square bracket. Here we have 12, 13, 14, 15. Okay. So close this bracket, square bracket, open the parenthesis. Now let us run here. So here we can give it np dot random shuffling. Okay. Np dot random dot shuffle will give it. Shuffle of r, my variable name r. Okay. Then we are going to print r here. Okay, let us take a look at the output. So here we go. See here, we have given 12, 13, 14, 15. And here we got 15, 14, 13, and 12. So this is a shuffling. So it modifies the sequence on place by shuffling its contents. Okay, so this is one way you can give it, or else we can give it in the other way as well. Shuffling, done. Okay, now let us look into the next function, that is unique function. And so what is this unique function? So it removes duplicate value from an array. Okay, hashtag it removes duplicates values from an array. Okay, enter. So here, how do we do that? So let's see, arr 2 arr equals np dot array. Open the parenthesis, open a square bracket. Now I am giving 1, 2, 2, 2, 3, 4, 4, 6, 6, 6, 7. Okay. 7. Okay. Close the square bracket, close the parenthesis. Now here we will be giving print unique elements. Okay, open this bracket, np dot unique. Okay, so np dot unique, here we'll give it array rr. All right, so here we close it. Now let us run here. We got it. So we got, see here, I had given a 2 times number 2 and 2 times number 4 and 3 times number 6. But here only 1 times it has been added. Okay, it's been displayed. 2, 1, 2, 3, 4, 6, 7. So these are the unique function. Now the next function is resize function. And so what is this resize function? So it creates an array of larger size than the original array. So hashtag it creates an array of larger size than the original array. Enter. Okay. So here we go. So what? Let us perform the operation here. So ARR2 equals np dot array. Open the bracket, square bracket. Here I can give the numbers here 1, comma 2, comma 3, comma 4. Okay, close the square bracket. Enter. Now here np dot arr np dot resize will give it np dot resize. Okay, and here arr2 comma 2 comma 3. Close this bracket. Now what I do, I'll print it here. Print resize array comma np dot resize open the bracket arr 2 comma 2 comma 3. Okay, now let us close it here. Here we go, let's run. So n is not defined. Okay, here we have to give a np. Sorry, here we go. It will resized arrays 1, 2, 3 and 4, 1, 2. The same thing we can do it, but here we'll give it a 3 comma 2 here. Let's see. All right, you got it. Resize functions. Perform the insert function. Hashtag insert function. Enter. What is this insert function? It inserts a value along the specified axis at a given index. So hashtag it inserts a value along the specified axis at a given index. Enter. So now let us proceed here. So R equals np dot array. Open the bracket. Open the here. So 1 comma 2 comma 3 comma 4 comma 5 6 comma 7 comma 8 comma 9. Close the bracket. Okay, enter here. So now here we give it a print R. Now see, if I give a print R, then you will get the same thing 1, 2, 3, 4, 5, 6, 7, 8, 9. You will get it. So here I'm inserting. So here I'll give it a new variable. I'll create it. X is equal to np dot insert r comma 1 comma 99. Okay, we can give it 20 comma 99. Okay, so close the bracket here. Then we print after insert. Okay, comma x. Here we go. And extended amount of access. Okay, all right. So here we can give it on the axis. If I want to give it an axis like 0, so here axis. So say this is okay. We'll give it an axis 0 here, or else 1 we can give it here. Okay, 1 axis done here. Okay, at the axis 1 here, the number is changed here. You got it. Like we this 99 has been added. For first it was 1, 2, 3, 4, 5, 6, 7, 8, 9. But now after inserting of 99 at the axis 1, so here we give it 1 comma 99. Here the 99 has been placed added here. Okay. Then after 2, so here we have a 2 axes only. Okay. So for 2D array, we use a axis 0 and axis 1. Okay. Then we have a append function here. Hashtag append function. Okay. And what is this append function? So it helps us to append to a copy of this array. Values are appended to a copy of an array. Okay. So let's append it now. So ARR 3 equals 3 equals np dot array open the bracket 1 comma 2 comma 3, close it, enter. So if we append underscore ARR equals np dot append ARR 3 comma, and I have to keep the values. So what values I have to append it 4 comma 5. Okay. Close the bracket, close the square bracket. Now print append underscore ARR. Okay, close here we go. We got it. So here first my array was 1, 2, 3, but now after appending we 4 to 4 and 5 is also added here. Okay, to the list. Now we have a delete hashtag delete function. Okay, enter. So here I can give it the ARR. ARR for equals np dot array, close the bracket 1 comma 2 comma 3 comma 4 comma 5. Okay, here we have not opened the bracket here, square bracket. Now let us close the square bracket, open, enter. Okay. Now here we'll give it s equals np dot delete 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 ARR4. Okay. np dot delete ARR RR4 comma, and here I just want to delete 1 comma 3. So here 1 comma 3 I'm deleting it. Okay, close the bracket. Now enter, print s. So here see 1357 here, like um see here the index value 0, 1, 2, 3, 4. Okay, so here I'm telling index value 1 has to be deleted. Okay, that is 2. You will not see the 2 here. And index value 3. So 0, 1, 2. Okay, so this will be deleted. 2 will be deleted here. 0, 1, 2, 3. Okay. 0, 1, 2, 3. This 4 will be deleted. Okay, 1 and 3. So this is how it works, delete functions. Okay. Now let's move ahead to the next function here. That is our matrix. Okay. hashtag matrix. So this matrix, it's a rectangular two-dimensional structure that is made up of rows and columns, as you guys knows that. That is performed here. A equals np dot array 1 comma 2 close this bracket 3 comma 4 close the bracket. Yeah, okay, enter. Now b equals np dot array in the bracket 5 comma 6 comma 7 comma 8. Enter. Now here print addition comma a plus b. A plus b. Okay. So let us perform it. So we got that. All right. Addition. Five plus one, 6. Okay. 6 plus 2, 8. 7 plus 3, 10. 4 plus 8 is 12. We got the output. Now the same thing we'll be doing it for the subtraction. Print subtraction comma a minus b. Here we go. We got the output here. Now the same thing, what I'm gonna do here is Control C. I'll give it Control V. Now we are gonna do ahead with transpose. Okay. So here print transpose of a slash n. I'm using the slash n so that it should go to the next line. Okay. Comma a dot t. Transpose the capital T we have to give it here. A dot t. Here we go. Transpose of a. We have given it. Okay. And here if we give b dot t transpose of 5 7 5 7 6 8. Okay, transpose of b. Here we go. Then after that we have a swap accesses. Hashtag swap accesses. So the swap accesses is nothing but it interchange two access of an array. Okay, it interchange two access of an array. Now here let me give you okay, we'll give it the same one. We'll just copy paste from here. Control C, Control V. Okay. So here instead of this, I'll be giving it only one. Here let us give it C np dot array. And I'm going to create this 3. Okay. 3 1 comma 2 3 comma 4 and here I will be giving it 5 comma 6 comma 7 comma 8. Okay. Then after that Yes, swap equals np dot swapaxes 3 comma accesses we are giving 0 comma 2. Okay. Then print swap swapped. Okay, let us run. So here we go, the swap accesses. Okay. So 1 comma 5, okay, 3 comma 7, 2 comma 6, 4 comma 8. We got it here. Then we have an inverse. Hashtag inverse. So what is this inverse? The inverse of matrix exists only if the matrix is non-singular. That is, the determinant should not be 0. Okay. So here for the inverse, let us give b equals np dot array, open the bracket, 1 comma 2, okay, comma 3 comma 4. Close it, enter, inv inverse, okay, inverse underscore d is equal to np dot line alg dot in inverse of t. Okay, enter, print inverse of t, inv d. Okay, here we go. We got the inverse here. Now the next function, we have a power function. So what is this power function? So we have 3 conditions in power functions. If n equals 0, that is identity matrix. So hashtag n equals 0. So this is an identity matrix. Okay, enter. Then if n is greater than 0 equals, okay, that is greater than 0. Here this will be your multiply. Okay, multiply. And here if n is less than 0, so this will be of less than 0. So here let us give this everything in the hashtag. Okay, if n is less than 0, here it will be of inverse to the power. Inverse power. Inverse power. So here what I'll do here is I'll copy the same thing. Okay. Control C. Control V, enter. Print matrix power 2 slash n, that is the next line, comma np dot linalg dot matrix underscore power here d comma 2. Here we go. Matrix power 2 here. Okay, 7 comma 10 and 15 comma 22. Power matrix. Now the last one in NumPy, that is we have determinant. Determinant. So now what is this determinant? It computes the determinant of a square bracket. Okay. So like for example, the same thing. Here we have to give it a determinant. So we copy the entire thing now. Control C and Control V. Here instead of this one, we give it a determinant. Okay. D gamma D here. Now let us run. The matrix power 2 is minus 0. Okay.
Yes, so that's it for today's session. You have just seen how NumPy empowers Python with advanced matrix and array operations. These tools are super useful in data science, machine learning, and scientific computing. To the channel, give this video a like, subscribe to the channel, and hit the bell icon to stay updated. See you tomorrow for day 27, where we will dive deeper into Python for data analysis. Until then, keep practicing and happy coding. Bye bye.